Hello there, my name is Anderson Mamana Uni, and I'll be starting with the testing and evaluation of non-point source effluent water impact to Sungai Kangka. And my teammate is Elisha, Gladys, Nuhidaya, and our supervisor is Mr. Nuzul. So let's begin. For the introduction, river, substantial natural stream of water supply along its path by converging tributaries and moving water dilute and decompose contaminant faster than stagnant water. For the wastewater effluent, significant contributors to a wide range of water contaminant issues. An effluent is sewage that has been treated in a septic tank or sewage treatment plant. It also referred to as trade effluent or wastewater. And for the third one is wastewater treatment is a vital component in any community without which waterborne pathogen can spread resulting in disease and degradation of receiving water bodies. And for the Sungai Kangka is located at Polytechnic Kuching Sarawak, Matang Kuching, and 25 km from town Kuching Sarawak. Our problem statement for this project is unknown water quality standard for Sungai Kangka Polytechnic Kuching Sarawak, continuous effluent water flow to the river from non-point source, unknown physical and chemical data for the non-point source effluent water.
Hi, I'm Hidayah and I will continue with research objective. First, to determine the characteristic of Sungai Kangka water quality in terms of physical and chemical parameter. Second, to evaluate the quality of Sungai Kangka water from non-point source different by physical and chemical parameter. Then, research scope. First, to analyze the physical parameters of water sample, which is color, odor, oil and grease, and also temperature. Second, to analyze the chemical parameters of water sample, which are pH, dissolved oxygen, biological oxygen demand, total dissolved solid, total suspended solid, chloride and phosphate. Third, this research is being performed at Sungai Kangka Polytechnic Kuching Sarawak.
For the literature review of physical parameter for color, watercolor is integral to the concept of optical water quality, which may be defined as the extent to which the suitability of water for its functional role in the biosphere or the human environment is determined by its optical properties.
Literature review for odor is stimulate chemical sense receptor, major source of complaint in relation to water quality in river.
Next, oil and grease. Present in wastewater in 10% approximately with a concentration range between 10 to 100 mg per L. Oil and grease also refers to a combination of substances that do not readily mix with water and are commonly used in industry and daily activities. For examples, include motor oils, lubricating oils, fuels, animal fats like bacon grease, and also cooking oils.
The literature review for temperature stated that the temperature was more likely to be limiting factors for high nutrients and algal concentration sub-areas, whereas the sensitive factors could be like in lower concentration sub-areas.
pH. pH is a measure of how acidic or basic water is. Acidic water contains extra hydrogen ions and basic water contains extra hydroxyl ions. The range goes from 0 to 14 with 7 being natural. pH of less than 7 indicates acidity, whereas a pH of greater than 7 indicates an alkalinity.
Literature review for dissolved oxygen is the amount of DO present in surface water depends on water temperature, turbulence, salinity, and altitude.
Chemical parameter, biological oxygen demand, which is BOD. The more organic material there is in the water, the higher the BOD used in the microbes will be.
Literature review for total dissolved solids, TDS, is the sources of material in TDS can come from nature, geological condition, and seawater.
Next, which is total suspended solid, TSS, used for monitoring of metal load if one's calibrate against total concentration of metal. Runoff water from agriculture and anthropogenic activities could be the cause of the high TSS concentration in the river.
Chloride. The chloride ion does not absorb readily onto mineral surface and therefore concentrations remain high in surface water and sediment poor water and low in sediment. Chloride is required for aquatic habitat to thrive. However, high chloride levels can have a negative impacts on ecosystems.
Based on the literature review of phosphate, the flow of fertilizers that contain nutrients, mainly phosphate and nitrate, into the surface water results in higher pH and proliferation of algal growth. Before we go into the methodology for each parameter scope, allow me to describe our sampling method for this project. The first step was to locate the non-point source of Sungai Kangkas before taking a water sample. The sample location was established in the second stage. The third stage, water samples were taken from 3 different points and stored in incubation container. In the fourth phase, each non-point source water sample was characterized or analyzed using physical and chemical parameters. And the last step, which is fifth step, included evaluating non-point source effluent based on the obtained data. As you can see here, this is the method of physical parameter for color. In this project, the color of water samples is determined by visual observation of water transparency.
Methodology for other physical parameter. There are 3 steps.
So this is the methodology for oil and grease.
Next, the temperature of water samples is monitored using DO or dissolve meter in this experiment.
This is methodology for pH.
Methodology for dissolved oxygen, DO, for chemical parameter. There are 8 steps.
Next, there are 7 steps for biological oxygen demand.
Methodology for total dissolved solid, TDS, chemical parameter. There are 9 steps.
For the total suspended solid TSS, which is methodology, there are 10 steps for all of it.
And this is the methodology for chloride.
This flow shows the chemical parameter of phosphate methodology. HANA instrument phosphate test kit was used to determine the phosphate concentration in a water sample for the phosphate methodology. In addition to this slide displays the results for each parameter, which is both physical and chemical parameter. There are values from 3 different parameter points to establish the differences between each value. Additionally, a standard value is supplied to indicate acceptable water quality. Next, let's go to the discussion of this project. First and foremost, I would like to mention the location from each point are different. As we can see from the list above, indicate that point 1 of Sungai Kangka is next to administration office, point 2 next to cultural building, and point 3 near to the parking lot that adjacent to water plant. To begin, the color value of each point indicates that all of the colors associated with water transparency were clear. This indicates that the water color's transparency value is acceptable as long as it is in the range of standard value. This is because Sungai Kangka is a natural freshwater stream that flows through the forest.
Discussion for order. The standard value is orderless. The order of water sample are not the same. Point 1 is nearly to the sewage area, while point 2 is more to stagnant water. The water is continuous flow. Point 3 is because the structure of the river that have stone and give reactions to the water to continuous flow.
Oil and grease standard value is 0.01 until 5 m that based on index quality I marry. It is because the quantity of oil and grease is just the minimum amount of the oil that can be observed at the trip water sampling point. So it means the river is almost free from oil.
Following that, water temperature is a physical attribute that indicates how hot or cold water is. As can be seen, the value of point 1 is somewhat greater than the values of the other 2 points. Additionally, the values of the finding remains within the accepted range. And this shows that there are no high rate of chemical and metabolic reaction, also lower amount of dissolved gases content.
The discussion for the pH is the quantitative measure of the acidity or basicity of aqueous or other liquid solutions. According to national quality water standards, the standard value is 5 until 7. The result shows that the 3 points of Sungai Kangka are clean on the level 1 as they are free from the harmful toxic waste.
Discussion for dissolved oxygen DO. The standard value is 1.0 until 7.0 mg/liter. The fish and other animals that live in the water need oxygen to live. Natural river generally cannot have too much oxygen. If oxygen's level are too low in the water, fish and other animals may suffocate and die.
Next is biological oxygen demand BOD for the discussion. Point 1 2.86 mg per liter. Point 2 is also the same 2.86 mg per liter, and point 3 is a bit lower, which is 2.23 mg per liter. And for the standard value is 1 until 12 mg per liter based on the NWQS, which is National Water Quality Standard. And our discussion is based on Auto 2021. BOD5 indicates how much dissolved oxygen milligram per liter is needed in a given time for biological degradation of the organic wastewater constitute. And second is based on the result and standard value. All three sampling point within the acceptable range of class river 2 river. This indicate the water have sufficient oxygen for the microorganisms degrade.
Discussion for total dissolved solid TDS. The standard value of 50 until 150 mg per liter. The total dissolved solid TDS are the total amount of mobile charged ion, including mineral salts or metal dissolved in a given volume of water, expressed in units of milligram per unit volume of water milligram per liter. Based on the results that have been obtained in experience, the TDS of Sungai Kangka for all sampling points lower than the value they indicate is acceptable to be class 2.
Next, discussion for the TSS, or known as total suspended solid. For the point 1 is 20888 mg per liter, and the point 2 is 20966 mg per liter, and point 3 is a bit more in the middle, which is 20870 mg per liter. Standard value is 50 mg per L plus more or less than 10% from the Jabatan Alam Sekitar Malaysia. Total suspended solid TSS is a particle that are larger than 2 microns found in the water columns. According to Jabatan Alam Sekitar Malaysia, for class 2 river, the TSS value should be 50 gram per liter, more or less than 10% or lower depending on the season. Based on the result that have been obtained in the experiment, the TSS of Sungai Kangka for all sampling point lower than the value that indicate it is acceptable to be in class 2.
For the chloride is based on water science simplified, the standard value is 20 until 75 mg per L. So that means the value from the water sampling is acceptable. Sungai Kangka is the natural water. It is still not affected by the current value effluent data. Water river is the natural source, so that means it cannot be the drinking water because the chloride does not contain in the water.
For the phosphate, based on Mahadevan 2020, the eutrophic condition of the basin is revealed and proper mitigation strategy was adopted for the removal of phosphate species using pillared clay materials. According to the results, the phosphate value obtained is within an acceptance range, which is 0 until 1 mg per liter, indicating that the Sungai Kangka is not contaminated and that the quality of phosphorus in the water will not pollute the Sungai Kangka.
The conclusion is, this project is about studying water quality conducted at Sungai Kangka Polytechnic Kuching, Sarawak. Based on physical and chemical parameters, we have studied in this experiment about color, odor, oil and grease, and temperature. In physical parameters, the water is clean, while on chemical parameters, which is pH, biological oxygen demand, dissolved oxygen, chloride, phosphate, total dissolved oxygen, and total suspended solid are also within the acceptable range. That means the water quality of Sungai Kangka is in good conditions.
For the apparatus we use is incubating bottle, weighting scale, dissolved oxygen meter, filter paper, chloride test kit, HANA instrument, phosphate test kit. And for the cost, we didn't use any, we only use Polytechnic Kuching Sarawak facilities.
For the reference, our Gantt chart. That's all from us. We would like to say thank you.